Pre-test, basically it's just the homework for tonight, the night before the test. They're all odd problems. The answers are all in the book, but I'm going to go over a lot of them with you. Let's look at number 7 on page 477. They're asking you to give an example of a quadratic function whose vertex is at the origin. That means the quadratic function is going to have its curve that cuts right through there at 0, 0. 0, 0 is the origin. Or it could go down from there. Or it could be thinner. Or it could be wider and go up. It could be any number of different things. Sorry, that goes through there. But it has to go through 0, 0. The way we write one that has that, we know that it has to go through x equals 0, y equals 0, because it has to go through the point 0, 0. In order to make the x coordinate 0, we have to make sure that negative b over 2a equals 0. So basically we have to make sure that b equals 0. If b equals 0, this thing is going to go through x equals 0. It's going to go through this point on the x-axis. Then to make sure it goes through y equals 0, we have to make sure c equals 0. So in order for something to go through 0, 0, b has to equal 0 and c has to equal 0. b equaling 0 makes sure that the x part is 0, and then c equaling 0 means the y part is 0. So if b is 0 and c is 0, it's going to go through the origin. So I could write one now. I could say 4x squared equals 0. So in this one, a equals 4, b equals 0, and c equals 0. So this thing is going to go through the origin. So for number 7, that would be a good example. Negative 2x squared equals 0 would be another example. As long as there's no x term and there's no other number just all by itself, which would be c, the thing is going to go through the origin. Let's look at number 9. Its graph is wider than y equals x squared. So we need something wider than y equals x squared. Well, remember, the a term is the thing that tells us whether stuff gets wide or narrow. If I had y, so let's say y equals x squared is just kind of looking like this. Y equals 5x squared is going to be steeper, right? Because it's going to get bigger quicker because of that 5 there. But something that's going to be wider, like this, which is what they want for the question, a is going to have to be between 0 and 1. It can be positive or negative, but the absolute value of it has to be between 0 and 1. Basically, it means it has to be a fraction. So if I say 1/5 x squared, that's going to work. Y equals 1/5 x squared. It's going to look something like this. It's going to slope up because this is positive, but it's going to be wider because the value of the absolute value of a is between 0 and 1. This basically just means it's a fraction. In between 0 and 1, it could be positive or negative. It doesn't matter. So that's an example of one that's wider than y equals x squared. And y equals 5x squared is an example of one that's steeper or narrower than y equals x squared. Let's look at 11, page 577, or sorry, 477. They want us to graph y equals negative x squared plus 1. So in order to graph for this, we're going to need a few points. You definitely need the axis of symmetry and the vertex. So the axis of symmetry x equals negative b over 2a. The axis of symmetry is always going to be x equals something, and it's always going to be the x coordinate of your vertex. So once we find it, we know it's going to be the x coordinate of the vertex. So I have a equals negative 1 because of that negative next to the x squared, b equals 0 because there's no x term, and c equals 1. So negative b over 2a is going to be negative 0 over 2 times negative 1, just going to equal 0. So the x coordinate of the vertex is going to equal 0. I put this parentheses there because I'm going to get my y coordinate now when I plug 0 back in. So in order to get the y coordinate for the vertex, I find negative b over 2a, and I plug that back in every time I see x in the original equation. So here if I plug in 0, 0 squared is 0, times negative 1 is still 0, plus 1 is 1. So the vertex of this thing is 0, 1. This is a very good place to start when you're graphing a quadratic. So I know this quadratic is going to start at 0, 1. We also know its y-intercept is 1 because c is 1. So that makes sense. It's going to go through 1 on the y. Doesn't necessarily mean the vertex is there, but in this case it is. So if we have 0, 1, we just need to graph 2 more points on each side. We can make up whatever we want for our x's and then just plug them in and get our y's. It's a little bit easier if we pick things that are the same distance from the vertex both ways. So I could say 1 and 2 and -1 and -2, but how about I do 2 and 4 and -2 and -4? Those are still the same distance away. They're just a little bit more than what we're used to. So I'm going to plug any of these in for our x and see what we get for y. So for 2, if I plug in 2 for x, you got to be sure to do the squared thing before you put the negative in, because in PEMDAS, exponents comes before multiplication. So before we multiply something by negative, we got to do the exponent. So 2 squared is 4. Tack on a negative is -4 plus 1 is -3. If I plug in 4 here, I get 4 squared is 16. Tack on a negative, -16 plus 1 is -15. I should get the same answer when I plug these in because they're the same distance from 0 as these are the same distance as these are from 0. So -2 squared is 4. Tack on a negative is -4 plus 1 is -3. -4 squared is 16. Tack on a negative is -16 plus 1 is -15. So these are my 5 points. Now I just graph them. So this is 0, 1. This is it looks like it's going to be our maximum because this thing's going to slope down based on a equaling -1 and also when I plot these points. So 2, -3, about there. 4, -15, way down there. -2, -3, down there. -4, -15, down there. You don't have to pick points that are equidistant from the vertex. It's just going to make it a little bit easier because these two are going to be the same as these two. So it saves you some work. But this is what this thing is going to look like. If they asked us what the axis of symmetry was, I'd say it's x equals 0, just like up here. If they asked me what the maximum was, I would say y equals 1 would be its maximum. I mean, y never gets higher than 1 here. So when they ask you your maximum or minimum, it's best to say y equals. If you just list the vertex, you'll probably still get credit. That's how you graph number 11. I'm going to skip 13 because it's very similar to this one. I'm going to go on to number 15. They want me to state whether it has a maximum or a minimum. So it's y equals -3x squared minus 7. If a is negative, a is -3, b is 0, c is -7. If a is negative, means it's going to open downward, which means it's going to have a maximum. It's going to have a top of a mountain. If you think of this as like a, I don't know, a mountain with like a trees or whatever. That's actually not accurate because the tree would be higher, but when we think of the top part of the mountain, this is going to be a maximum. When it slopes upward, or when you got a valley, the bottom of the valley is going to be the minimum. Since this one slopes downward, it's going to have a maximum value. 17 is also going to have a maximum value because it's -x squared plus 6. So a is -1. So again, if a is negative, it's going to slope downward, and that means it's going to have a maximum value here. We don't need to know what the maximum value is, but if we needed to find it, we'd plug in -b over 2a to get the axis of symmetry, and then we plug whatever we get for that in back for x, and then whatever we get for that, sorry, this should be y equals, whatever we get for that would be our maximum, whatever we get for the y coordinate after we plug -b over 2a in for x.